Hello ladies and gentlemen, my name is Decryption and I hope you are well. So one big thing I've been planning for a while that we're going to look at doing soon is upgrading the AI in this game. I want to give them loads of features, and in order to do that we need a solid framework, otherwise it's going to quickly become very messy. So what we're going to do today is look at one of the ultimate AI frameworks, Utility AI. We're going to discuss what it is, and we're going to have a quick preview of what we're going to do, but it's going to take a few videos to actually create everything, but I'll still be able to show you what it is. So let's get started. So I'm doing this video a bit backwards at the moment because I have the finished product here, and then I'm going to revert to a previous one. I'm going to remake it just to follow along in the tutorial, right? Because it's better to explain it all so you know what it's doing if you need to make any changes. So let's have a quick look at what we are going to make today. So I'm just going to jump over my dev scene here. So what we have is we have this NPC here, right? But I want to give him tasks he's allowed to do. And then those tasks will check themselves and say when they can do it, what they're supposed to do, and all of the stuff like that. In the previous video, when we explained Utility AI, we talked about a farm and a farmer and whether he should start farming or not. So the system we're going to look towards building today is going to be the first part of it, where he can execute tasks and stuff like that. So on the NPC, we're going to have this new brain component that we're going to create. This brain component is going to have, at the moment, a couple of variables. It's not going to have a schedule. We'll do the schedule in the next video because it's a lot of work to do that, and I'm trying to split it up so it's not a 2-hour long video. But we are going to have the always available tasks and the dynamic tasks, and then a couple of the other ones, right? These tasks, if I open it up, are things you create in blueprints to assign stuff. So at the moment, I've got a user state tree one where they can tell it to use a state tree of anyone you want, or a debug one, which is very, very useful, where you can come in and you can literally say what the debug text is, and it will print this text out. That's it, right? There are a couple of other things, like it's got a display name for debugging later. It's got some gameplay tags, so you can say whether or not this task can be completed. You could argue those tags might be better in a choice-based system, but with me using gameplay tags so heavily, it's nice to add it at task level so it can avoid just hitting it anyway. We've got the score, so that's what the base score of this task will kick out. For some things you might say, oh, it's a high score by default, 5. Some things you'll just say it's a base score of 0. It doesn't matter. And then you've got some extra selections down here, whether this task can be interrupted. Can it be just immediately stopped and another task of higher priority be told to run? Or can this just not be interrupted at all? So like flicking a switch, you don't want to interrupt in the middle of it because it'll glitch the animations out. Look, we have the priority. This is only used if 2 tasks score the same value. The highest priority will win. If they're both the same score and the same priority, it'll just pick the first one. And then we have forced selection. Should this task, no matter what it does, just be picked? That's great for go and attack this enemy if an enemy spawns right in front of you. You can just add the goal and say forced attack. It's really nice to have. And then we're going to look at the dynamic tasks, which are the same thing, but they've got a few more options to it when you add to it, such as remove when it's finished, or is it always enabled and stuff like that. We've also got the timers, so how often should it reevaluate the current task? We're doing little timers on it, just in case you have a task that should be reevaluated. Maybe you tell them to run a state tree that's infinite, but you add an evaluation timer and say after 5 seconds, reevaluate whether you should still be doing that or not. And we also have a switch threshold, which is how much time it gets before switching to the new task, just so you've got time to fade out. That's what we're essentially going to be building today. The tasks are super simple. Just event execute, do whatever code you want. That's it. So you can see I've got a timer with a print string, and then it calls finish task. We aren't going to be covering the schedule part yet, because it is a big subsection, but we're going to break it down into 2 pieces. We'll do the basic schedules, like the periods, and then we'll look at adding this new fancy timeline editor we've wrote into it, so you can easily drag your schedules around, align them up, and tell it exactly what to do so you know you've got everything where it needs to be. That's going to come in a later episode because that's very C++ heavy, that one. You can only do that in C++. But all of this brain stuff and the tasks, if you really wanted to, you could do it in blueprints. You won't quite have the same efficiency or the ability to just drop down and edit tasks right here like that, so I can come to debug and open it up. That's unfortunately got to be C++, but it's super easy, I assure you. So if you stick with me, we'll crack it. So I'm going to revert to an older version now where I don't have any of this in, and we're going to start cracking it out. So I've cleared all of that out of my system now, keeping backups, as you can imagine. And we are going to talk a little bit, before we crack on, the design decision that we're going to be going into in order to try and make it easier for you to understand. So basically, in Unreal, you have your NPC, right? This will be any NPC in your game that you want to issue commands to, which will probably be most, yeah? What we're going to do is create a new component for them called the AI Brain. This is going to be in charge of storing all of their available tasks and their dynamic tasks. Just any task they can do. That's the point of the AI Brain. It will control the tasks. Eventually, it'll control the schedules, but it'll handle the playing, the finishing, the exiting, all in a nice wrapped component, right? It's not to be confused with the brain component that the state trees and the behavior trees inherit from, if you know that deep of Unreal. It's a new type of AI brain. You call it whatever you want. AI brain, AI command system, NPC brain component, something like that, right? And what that's going to do is all of these tasks will have a task definition. That's what it's going to be made up of. And this will connect to multiples of these, like so. Each one of these tasks is going to have a score it needs to run. And then whenever it runs these tasks, it will pick whichever one has the highest score and then run with that one. And it might be it runs a state tree, it might print a string, it might print a behavior tree, anything like that, but it will run it. And that's what our basic one's going to look like. In the next episode, once we've finished all of the basic task running, we'll add the scheduled system into it and we'll come and revisit this graph so you can understand it. But essentially, all we do is shimmy this down a little bit and put the scheduler here in between. So we are going to have to do this in C++. Technically, you don't have to. You can do it in pure blueprints. It just won't be as nice. So at the moment, we can create a task definition, assign it to the AI brain and say, run this state tree. And then we can specifically tell it what state trees to run. But if you do it in blueprints, you'll have to create a separate task definition for every single type of state tree. It's going to get very, very messy. And that's just with a setting we can set in C++. Sadly, Unreal doesn't expose that in blueprints, so we kind of have to do it in C++. But all the code's going to be in the description below, and all the blueprint code will be in the description below as well, thanks to the graph capturer tool, so you'll be able to hopefully make your way around it. And of course, if you run into any issues, comment below or reach for me on the Discord. We've got a channel where everybody helps each other out. So let's jump into Unreal then. So if you haven't got a C++ project yet, back your project up, we'll convert it over. It's super simple, and I've never seen it actually fail. If you can load Unreal up, you tend to be able to do the C++ already. But if not, reach out below. So make a backup of your project just in case, but it's always good to have that anyway. And then to convert it to a C++ project, just go to Tools, New C++ Class. And for those who already have a C++ project, follow along anyway, because we're going to create our first C++ class. Now, the first class we are actually going to create is we're going to start from the bottom and work our way up. Because the AI brain needs to know the task definitions, right? But the task definition doesn't need to know about the AI brain. So we can't create the AI brain and say, hey, you know what a task is, because we haven't created the task yet. So if we do it backwards, we can create the task and everything to do with it, and then we can create the brain and say, hey, here's your tasks, essentially. So it's a bit easier. So we're going to start with the task definition first. So back in Unreal, on our new parent class one here, I'm going to select all classes, and I'm going to click this object one at the very top, a very, very base Unreal C++ class. It doesn't have world access, it doesn't have actors or anything else like that. It is super lightweight. You can't drag it into the scene, but that's perfect for what we want to store, little bits of data. Think of it a little bit like a data asset, but even lighter. So we'll tap next on that, and I'm going to come and call this one NPC task definition. You can call it NPC task if you want to. I've called mine definition because technically you're defining what a task is, and then we're going to create children of it later, but it's up to you. And then make sure your project's selected, and then just click create. If you've got a C++ class, this is going to be relatively quick to do. If this is your first Unreal project and it's not a C++ class, it's going to take a little bit of time to chug through, but give it some time. See, mine's already done. It didn't even take that long. So I can come back and open Rider up now. So I'm using JetBrains Rider. It's free for non-commercial use, but I pay for my version anyway. So it's up to you. If you're on Linux, just use Rider. Honestly, it's the best thing you'll ever do. If you're on Windows, you probably have Visual Studio installed, but Rider is also a very good alternative to use. If you're on Mac, again, just use Rider. That Xcode thing you have, I've never really gotten on with it, so it's up to you. And remember, all this code is going to be in the description below, and I'm going to try and explain everything I can super basically. I'll start by saying a short description for those who know what they're doing in C++, so you can just crack on with it, and then I'll break it down for those who aren't confident, and we'll work through it. So the first thing you'll see is we've got two files now created, an NPC task definition.h and a .cpp. A .h is your header file. This is like your blueprint class. You store your variables in it. You store your function names, your event names, all stuff like that. The C++ is your actual code. This is your event graph, your construction graph, your function graphs, right? That's where you put the code. So, inside the .header, we're going to start there and we're going to create all our variables. Now, I have got a list next to me of all the variables we need, because as you can imagine from the beginning, there's quite a lot. But it's super simple to do. So the first thing we're going to do is create a variable, or a property as we call it in C++. So I'm going to create a display name just for the debugging purposes. So this means when you're scrolling down the list, you can just take a look really quickly and know exactly what a task does. You don't have to look at the task, figure out what it does. It's a simple name, if you wish, just to make it really quick. So it's a type of text. So in C++, we use f text, capital F, capital T, space, and I'll call it display name, and I'll put semicolon, right? But in order to give it all its properties, like is it instance editable, what category is it in, we need to give it some metadata. So I'm going to say this line below is a U property, or an Unreal property, Unreal variable. So all in capitals, U property. And you'll see that my rider will automatically auto-complete. So I'm using the IntelliSense going, based on what you've typed below, is this what you want? I'll explain it if it does, because it just saves everybody typing. If you're using rider, you'll get the same thing. So I'm just going to press tab here, just to auto-complete it. Edit anywhere means the C++ can edit it, and we can do little bits in the Unreal Engine, great. Blueprint read write means we can edit it in blueprints, but I don't want to do that. So I'm going to set this to blueprint read only, right? So that means blueprints can read it, but they can't write to it, because we don't need to change the display name, it's for us only. The category, this is how it categorizes your variables in the editor. I'm going to set this to task. And there's our first Unreal property, right? To make it nice, you might want to hover over it and add a little tooltip. Just add a comment above it. So press enter, put 2 forward slashes and type out what it is. So I'm going to put for debugging only, this is the display name of the task. So now in Unreal, when we hover over this, it will say that text to us. You'll notice we've got a red squiggly line. So if you just hover over it, it will tell you blueprint read only should not be used in private members. So a private variable, basically anything in here is considered private unless we tell it otherwise, meaning nothing else but this class can access it. So the blueprints couldn't even see it. But we want this to be read by blueprints. So all I'm going to do just above is press enter and type public and add a colon. And you'll see it will jump back to the beginning. That's completely normal. Let it do it. It's so it separates the code as you're scrolling down. There's our first variable, right? The other variables we need, which I'm just going to run through really quickly for those who know what they're doing, is a base score, which is a float, a gameplay tag container for both required tags and block tags, a boolean called b can be interrupted. This is so you can interrupt the task later. An integer priority, and then we need a couple of functions, a function for can running, which passes in the brain context, which we'll get to in a moment. So those who aren't fully confident, all we're going to do is copy these 3 lines, paste it right below, and give it a little space to make it easier, right? This next one, I'm going to set the text to the default score for this task, and you don't have to add full stops at the end if you want, I do. I'm going to make sure that this one is the exact same, but I'm going to set the category to scoring, just so it's a bit different. And I'm going to set this to a float base score, and I'm going to get a default value of equal 1 point f, which means it's a floating point. Yeah, super simple. The next one, we're going to add the gameplay tags in, so I'll add a comment. Any gameplay tags the NPC must have to be able to perform this task. So it might be if the NPC is on fire, you cancel out some of these tasks and say run around instead. You know, it's little bits like that are really helpful. And you can see it's automatically wanted to put it in for me, so I'm just going to press tab. But essentially, you want U property, edit anywhere. Technically, we're going to check these in the C++, so I'm not actually going to put the blueprint read only in. For this sake, the blueprint won't even know this exists. And I'm going to set the category to be task pipe tags, right? And you'll see it's erroring down here because it needs to add a F gameplay container and it doesn't know what that is because it's a built-in Unreal one. So I can hover over mine, press Alt Enter, and it'll say, do you want to include this line here? So I'll click yes. And all that's done is come up here and added it right here, include gameplay tag container. Now, you may get an error later, so we'll cover it now. If you scroll down in your source, wherever you are in your Solution Explorer or in Rider, and double click your build.cs file for whatever your project is, this is basically all the classes your project knows how to use. So core, UObject, and engine is all Unreal. It's saying you know how to use Unreal. Great, that's why we can use ftext and stuff like that. All the rest we don't need to worry about, but the one you need to add inside public dependency modules that add range, right at the end, just add gameplay tags in quotes with a comma. So if yours similarly looks like that, comma, add your curly brace, gameplay tags, like so. That just tells Unreal, hey, this is how you use gameplay tags. Great. So I'll come back to my definition.h. We've got the required tags now. I'm going to duplicate all this by pressing Ctrl or Command D, and I'm going to add any gameplay tags the NPC must not have in order to perform this task. So this might be if you must not have the tag of fire in order to produce this, or you must not have the tag of is dying or is poisoned, you know, anything you want. And I'm going to keep everything the same, but I'm going to rename the variable required tags to blocked tags. And that's our gameplay tags one's done. Next, we're going to need another variable, so I'll duplicate this below. And this is going to be whether this task can be stopped or taken over by other tasks. And I appear to have deleted a bunch of stuff, so I'll just add that back in like that. And this is essentially that. It's going to be a boolean that says this task can be either interrupted or it can't. So if they're farming or if they're walking, you can mark it as interruptible. And if an enemy shows up, they can immediately stop the task and do it. If you don't mark it as interruptible, they will have to finish walking to where they go and then want to fight the enemy. So this will be a uProperty edit anywhere, and we can give it a category of just task. That's fine. And I'm going to set it to a bool, which is a boolean, and I will call it B can be interrupted. And I'll set it to true by default. You'll wonder why we put the B there. That's just an Unreal C++ convention. It's pretty much just, you know, you follow along with it. The final one, let's just see if you can do it, just if you're not confident, is a priority one. It's a type of integer, and that's going to be if two tasks have the same score, the priority will decide the winner, otherwise a random one will just be picked. So pause the video and see if you can crack that one out, because it's super simple, but we'll cover it in a minute. Did you crack it? So I'm going to duplicate this one. I'll set the comment to be if two tasks have the same score, this is used to determine which one should run, otherwise it'll default to the first one. This one will be edit anywhere, and I'll just keep the category as task, and it'll be a type of int priority. And I'll just default it to 0 for now. There we go. So there's all the variables we're going to use in a basic task first, right? But there are a couple of other things that we need to start adding now. Firstly, we need to add one more variable, which is just to say that this task has finished. Because it very well could be one task has multiple ways of finishing, and if you call finish once, that's immediately going to go back to the brain and say, hey, I've finished, give me a new task. But if another part of that task calls finish as well, before everything's sorted itself out, it could end up trying to get two tasks to run and cause a few issues. So I'm going to create another boolean below, which is just going to be finished, and I'm going to default it to false. Make sure it's false, otherwise you run into errors later. I'm going to remove both of the edit anywhere and categories from it, just so it's a uProperty, and I'm going to set the comment to private bool to track if the task is finished. So how do we make it private? We just press enter above it, type private and a colon like that. So we've got public, there's everything we can see, and we've got private down here. So nothing except this task needs to worry about that be finished. That's what we're basically saying. Now that we've done that, the next thing we need to do is look at creating the functions that this task is going to use. And this is specifically going to be, can this task be run? That'll be some checks like, is the NPC alive? Has the NPC got the required tags? All weird stuff like that. And then another one will be the score. This is the one which will actually return the score that you'll use. Then the other three are going to be the execute one, which is the task running. The tick task, so that's useful if you want a task that ticks, often checking distance or something like that. And then the final one is the finish task, which is to say this task is done. However, all of those require quite a lot of info for us to potentially be useful in the future. So for example, when a task is running, it'd be nice to know which NPC is running it, because then you can grab their location or do whatever you want. It'd be nice to get the ability system component if you're using that, If you're using the gameplay ability system, it'll be really nice to know that sometimes if they're doing attacking. And equally, it'd be nice to get the world time, because if you are ticking or something like that, you might want the world time. But adding all three of those properties to it can get a bit funky, because we're going to be copying and pasting a lot. So let's create a structure to handle it, but in C++, because it's easier to pass around. So it's super simple. Scroll up and you'll see this uClass property here, which is basically saying your class for the NPC definition is a type of Unreal class, right? We've got some stuff to add to that, but we'll come back to that later. So above the comment as well, and just below all of the includes, we're going to create our struct. So I'm going to say we're creating a new uStruct, and in brackets, I'll type blueprint type. So it's a type of blueprint struct if you wish. Under it, I'll create our struct, which is the data type, and then I will call it FNPC brain context. And I'll press enter and I curly brace and press enter again. And notice it's added the semicolon at the bottom. I don't know why Unreal defaults it to F instead of S, but it basically stands for a struct in Unreal terms. Inside here, it's exactly the same as our class. We can add all of our variables we want to store. Now, because it's a type of uStruct here, Unreal has some special logic it likes to add to it when it's building it. So we're just going to copy this generator body and just paste it inside here like that. And I'll press enter under it. And that's just going to basically say, when Unreal's compiling this code, go and run the generator body function or macro and add loads of little bits to it just to make it work nicely. It's a nice little work that you can do with Unreal and C++. So the first one I'll create is our pawn. So uProperty, and it'll be edit defaults only, which means we can edit it in Unreal when it's in the details panel, but we can't edit it anywhere else, which is exactly what we want. And I'll also say it's blueprint read only, which means the blueprints can read it, but they can't set it. We don't want to be changing which pawn is running something. That's just strange. And so in here, I will say a pawn, and I'm going to put a star and type pawn. So the pointer here basically says, don't copy all of the data that this pawn is. So if you imagine you've got your NPC, they've got all their components, they've got their logic on it, their ticking, whatever, their meshes, right? If we don't put the star, we're going to be saying, take that, copy every single thing and move it into memory. So we've got two places in our RAM holding that NPC. That's not great, because technically they're different instances as well. But a star basically says, hey, store this pawn, and then every time we call this variable, go to that memory location instead. It's a pointer. We're pointing to that memory, which is good. After this, I'm going to copy it below, and I'm going to add the ability system component, because I'm using that in my game. So I'll do ability system component like that. It'll be a pointer again, and I'll just call it ASC, ability system component. Like so. So if you are using the ability system component, because this is a special type, instead of including it and saying, hey, you can use this, technically this is going to compile before we want to run it. So if you imagine Unreal looks at all of the code that it runs and one by one it goes compile, 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 right? We don't want to include it up here for it to go and compile it, for it to come back here to say it needs to compile it to go back to there, because it's just going to run into issues. So what we can do instead is just tell it, hey, you've already compiled this, just go and fetch it. So instead of include, just below, we will type class ability system component like that. That's all it means. It just means go and grab this class that you've already built. So then that will work, but only if you're using it. The final one we'll do is, again, another uProperty in here. It's added brain context, that's completely wrong. We'll just do float without the pointer, and we will do world time. So that's how fast the game is ticking, so you can do things like make it match 60 FPS without ruining your physics or something like that. And that's how a struct pretty much done, right? But because this class here is going to need this struct, we need to kind of tell Unreal, hey, compile this struct first and then come and compile this. So underneath this class here, I'm going to press enter, and I'm just going to type struct FNPC brain context. So as it reads down here, it'll say include all of this. Oh, I've already included this, include this. Oh, I need this, so go to here, compile this, come back to here, we're all good. And then come down here, and then it'll compile this. So yeah, you get used to it, but again, all the code's in the description anyway. So I did say we had to add some stuff to this uClass here, so just on our NPC task definition. So inside here, we're going to add abstract, which means we can't drag this task into the world. We must make a child of it. We can't just directly use this, because this has no logic to it. It's not going to have run this state tree or anything like that. We'll make children for it. I'll then set blueprint type, which means we can see this in the blueprint class list. I'll then set it to blueprintable, which I believe does the same thing, or at least you can create blueprints of it, just put both on. I'll do edit inline new, which basically allows us to do that custom thing where we can drop down and choose state trees per task definition instead of having to assign idle state tree, assign this state tree, assign this state tree. We can just create one set state tree and change the variables. And then finally, default to instance, which will just do anything we've defaulted in here, use that by default. Edit inline new lets you change it. So we need to put those on there just to make it work right. Now that we've done that, we can scroll down and we can start working on our functions that we want to add in. So functions are a little bit different in Unreal because there's two ways you define them. You first define the function just like we've defined a property here, and then you define the version that you can override. Because of course we want to overwrite each individual task one to say, here's how you get your score. Can you run or not? But it's super simple. So underneath priority, I'm going to press enter twice. I'm going to do // and we'll do our first can run function. So I'll add the comment in, which is going to be whether this task is allowed to be run. By default, it checks if the NPC has required tags and doesn't block any tags. So it does a little bit of logic, but we can overwrite it. So inside here, I'm going to say it's a U function. And in brackets, I will say it's a blueprint native event, which means we can see this in blueprints, we can run it, we can overwrite it. Under here, I will type bool because it's going to return a boolean. Can it run? Yes or no. I'll say can run and I'll open brackets. Inside here, we want to pass this structure here. So when we're calling this function, we can access the pawn, the ability system component, the world time. So inside here, I'll type const, which means, hey, this data type we're passing in, you can't modify this. It is set. That's it, right? And you can see it's already wanted to do it for me. So I'm just going to press tab. And all it's basically done is added our F brain context up here into it, and then it's got this ampersand which we'll talk about in a minute, and it's just called it context, so that's all good. The only other thing we'll do after the brackets but before the semicolon is type const, which just basically means everything in here, once it's run, that's it, don't edit it. So whereas the star or the pointer says don't duplicate this, just use that one over there, right? The ampersand is called a reference, and it basically says, hey, go and get that, but just let me have it. Don't copy it, just go to it. It doesn't point to it, it simply references it, like an alias. So we're kind of saying, hey, if you ever think what the context is, go over here. That's basically what it does. You'll get your head around it eventually. On the next line under that, we've added our basic function, but we now need to tell Unreal, hey, you can overwrite this in blueprints, and it's super simple. Just copy the line above and paste it right below, and then after the function name, so can run, do underscore, implementation, specifically like that, and you'll see it'll turn green like that. And that's it. That's all you literally have to do. We can start coding that in a minute, but we'll just create our other functions first. So we've just created can run and made it everything we need to do. The next one is we need to do the score, which returns a float. The execute, which returns void, it does nothing. It doesn't return anything. Tick task and finish task. So give that a go based on what we've just done if you're not confident. Otherwise, crack straight on if you know what you're doing. So let's make these functions then. So the first one will be score. I'll add the comment, check the score of this task, and let's see, it's pretty much just done it, look. So we'll just press tab, look. So it's doing get score. I'm going to rename it to score, actually. I prefer score. There we go. So score, passing in the F context, implementation. That's exactly what we need it to do. I'll press enter below. And this is why I love Rider, because it does make it so much quicker to do sometimes. Sometimes it gets it wrong, so you got to check it. I'll add the next one, which is going to be our execute. So run the action associated with this task. I'm going to call it execute because I much prefer calling execute when we run something. Makes you feel like a true hacker. There we go. Execute, passing in the brain context, and it's passing void look because it doesn't need to return anything. We'll do the next one, which is the tick task. So this one will be tick the task for repeated execution, and you can see it's done tick, but I'm going to call it tick task instead so it doesn't get confused with event tick because it differentiates it, and that's going to return void again. And then the final one will be our tell the task to finish. Oh, there you go. It even knows what we're trying to do before I've even done it, look, because it kind of assumes that's what we're going to need. Tell the task to finish, and we've got a finished task, I'm going to call it, so it doesn't get confused with anything, and it's more specific. There we go. But the only difference is, with finish task compared to these other ones, is these ones can be just called by C++, that's fine. But the finish task, we also want to make blueprint callable. So we can, in the blueprint, say, hey, finish this task now, we've done. But that's the only difference. Every other one is the same, except that one, right? And I've just been looking down my notes, we've actually forgot one variable as well. So I'll come back up to where priority is. I'll press // and we need a force selection boolean. And this is basically when we add or create this task, if we tick force selection, it will run that task right now. So we'll press tab, it will basically select this task to run no matter what as soon as it selects it, because it must be done right now. So for example, if somebody sets on fire and your task adds the fire task to them, as another task, we can say force run this task. And we can also tick it as interruptible, so it immediately runs. And it's called it be force run. I'm going to rename it to force selection, which will make more sense later. And I'll default it to false, because I don't want everything doing that. But there we go. There's all our variables, there's all our functions. Now, there's only one last thing we need to do inside the header file of the task definition, and that's to give it an event dispatcher, or a delegate, you might know it as either one, just so we can tell other things when it's done. For example, the brain component will listen to this and say, hey, tell me when you're done. And then this will go run, 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 and when finish task is called, it will tell the brain, hey, we're done now. But we don't want to create a circular reference where the task knows about the brain, and the brain knows about the task, and the task knows about the brain, and the brain knows about the task. That's called a circular reference. It's going to get code all confused. So we want to separate it off, and the NPC task will just say, hey, I'm done. That's it. It doesn't care who's listening. But the brain's sat there with a microphone going, haha, I hear you now. You're done. And that's it, right? So it's super simple. Scroll up to the top. Just above your U class and the comments here, you can even add a comment to this if you want. And we'll just say, an abstract NPC task definition to define all tasks that NPCs can perform. Something basic like that. It just had a tooltip somewhere. But below the struct and above that, we're going to tell it to create a new event dispatcher or delegate, right? So all in capitals, so hit your caps lock key, we're going to type declare underscore dynamic underscore multicast underscore delegate underscore, and then you have to pick which one you're using. 1 param means you've got one parameter in the delegate or the event dispatcher. 2, 3, 4, 5, 6 means you've got that many variables. For us, we just want 2 params, like so. Press enter, and the first one, we have to type the name of the delegate. So F on task finished, press comma, and now we have the data type of the variable, comma, the name. Then the comma, then the data type, then comma, the name of it. So we want our U NPC task definition, and this is going to be this task itself. So when we call on finished, it will say, hey, this is the task that's finished. We of course don't want to clone anything, so put the star or the pointer on it so it says, hey, this task over here is just finished. And then in the next comma, just name it something like task, yeah? After task, press comma, we'll do our second one, which will be the brain context. So F NPC brain context, which is all of this stuff up here. Press comma, and we'll do context, and that's just the context of it, like so. We're not going to put a pointer to here, because Unreal gets a little bit flaky when you're passing structs via delegates, so it is going to copy it at that point, but that's okay because it's going to be a one-time thing. The brain might want to do something with that, that's fine. And now that we've defined our delegate, we just actually need to use it. So scroll back down to the bottom, and outside of the private, because we don't want to put it in there, but under the functions, I'll press enter, and it's a type of variable, so I'll do / call when the task has finished. And my spelling is atrocious today. Press tab, and you can see mine's already done it for me. So U property, blueprint assignable, that's what we want because we want to be able to bind onto it in blueprints. On task finished is our delegate that we've just created right there. And I'll just call it on task finished. That's the name of the event dispatcher or the delegate. And that is pretty much all of the variables. So take a deep breath. You've done all of the major variables for that now. It's looking good. We can now move on to the C++ side, which again is all below, but the C++ side is super simple for a task because essentially we're going to do all the tasks logic in blueprints, right? So back over to the task definition here, you'll see it's very empty in the C++, but we need to add all our functions there to say, hey, this is what you're going to do. So super easily, come back to the header file and find your first function, can run, click the can run implementation and press Alt Enter or right click it and choose generate definition in this. If you're in Visual Studio, I think you have this version, but in Rider you absolutely do. I'm just going to press it and you'll see it's automatically created everything we need in there. It's got an error because we're not returning anything and we're saying, hey, return a bool, but we'll come back to that. Let's do it for all the functions. So can score, generate, execute. I believe there's a way to make it do all of them, to be honest, at once, but never mind. We'll just do it one by one for now. click on all of them, and just make sure you choose generate definition. And you'll see they'll all fix themselves like that, look, yeah? So, super simply, in the float score, we're just going to return 0.5f. That's it. You can return anything you want. I thought 0.5f was a good median score, right? And I'll do return base score and semicolon. That's it. Super simple. By default, return the base score 1, 5, whatever you set it to. Execute and tick task, we're going to leave completely alone. We won't touch them at all, but you need to define them. Finish task, super simple. We just need to tell the brain or our event dispatcher, hey, we've finished. So we'll add our blocker fixing to make sure we don't call finish twice. I'll say if, open brackets, be finished, press tab, and I'll press enter. Don't press tab again because that was actually wrong. It wanted to show us there. And I'm going to just type return, which basically says when it comes into here and says finish task, have you already finished? Yes, return, go away. Don't do anything. That's what it's saying. If we haven't finished already, it'll come inside here. So we can set be finished equal to true like that, which means if anybody else calls finished, it's going to be blocked. And you can see, yes, Ryder, you are right this time. Now it wants to call onTask finished, which is our delegate we just set up, or event dispatcher, dot broadcast, which means, hey, shout it to the world. This event dispatcher is telling everybody something. And it's saying this task with this context we've passed in, which is nice and simple. Yeah, that's the finished task one. Now we can work on the can run default logic, which will be to check those gameplay tags if you're doing that. If not, just return false for now. But what we're going to do is we're going to first check, hey, have we actually got an ability system component to check against? If you're using a custom gameplay tag, you'll need to find a way to access that through your pawn. But for me, I'm going to say if the context dot ability system component, and I'll press enter and press curly brace under it like so. And that's basically saying, hey, does this character have a valid ability system component? If it does, all good, we can carry on. If not, we will return true. So by default, hey, you can just run. For those who aren't using an ability system component, you probably would be better running true by default, but it really doesn't matter. It just means if you don't overwrite this function, everything's going to run by default, which means it'll come to the score. If you return false, nothing's going to run by default. So it's a bit easier if you set true. So inside here, I'm going to say if, and I'll open brackets, and we're going to type context.abilitySystemComponent, and then I'm going to do an arrow like so instead of a dot. And an arrow basically says, hey, get this ability system component that we're pointing to over there in the brain context, and actually go into it, go and fetch it. So the dot is saying, hey, give me the ability system component that you've stored there. Yep. And then we're saying, hey, get this ability system component, travel over to where the memory is, and read the data. You don't need to understand it if you just follow the same syntax. It can be very confusing, and it took me ages to get my head around it. And I am still fuzzy a little bit. So inside here, when I'm going to say, has all matching gameplay tags, and I will just type required tags like that. So we're basically saying, has the ability system component got all of these required tags? But I want to say, does it not have all these required tags? So just at the beginning of context, I will press the exclamation mark, and you can see it's already done it, return false. So if you don't have all of these required tags, return false, they can't run this. It's a required tag. If required tags are empty, this will just be ignored. Now on the next line, we're going to do the exact same thing, and it's almost actually done it all for us already. But we're going to type it out. If, and this time we don't want the exclamation mark because we actually want to check if they've got any of the blocked tags. I'm going to say context.abilitySystemComponent pointer has any matching gameplay tags, and it's not forbidden tags. I don't know why it called it that. We want blocked tags, and then we will return false under it. So what we're basically saying here is, have you got any of these blocked tags? You're on fire, you're poisoned, you're dead. If so, return false, you can't run this task. Super simple. And that, ladies and gentlemen, is our task definition done. Yeah, that's it really. If you close your Unreal now, let's just do a quick test to make sure it's compiled. We're not done yet, but we are getting there. So we can click play now and see if it compiles. If you get any errors, run through your code, compare it to the one on the website to make sure you've not missed anything. You might have missed a semicolon, a bracket, a space, or you could be anything. I highly recommend a tool called Meld. It's free, M-E-L-D. You can click file and click blank, paste your code in, paste the website's code in. It'll tell you what the differences are. So if I copy both codes in, you can see they're identical, it should compile. If I make a couple of changes, you can see it's saying, hey, these codes are different. So you can see this one's missing a semicolon, this one's got a tab deleted, this one's missing a semicolon, you know, stuff like that. It makes it easier to compare. And mine's still compiling, so I'm just going to pause the video until it's done. And you can now see we are back in Unreal with that compile. So let's just come to our AI folder, or any folder you want. Technically we have tasks, but they're state tree tasks. So I'm actually going to rename them to state tree tasks to make it a bit easier for myself. And then I'll create a new folder and I'll just call it NPC tasks. This is going to be the actual behavioral tasks that I'll call other things. Let's create our first one, and I like to create a debug one for helping out. So I'll right click blueprint class and we'll search for our task definition, and we've got our NPC task definition right there. An abstract NPC definition used to define all tasks. There's our tooltip. Click select, and I'll call mine MTD, NPC task definition. Call yours TD for task definition, whatever you want. And I'm going to call this print string. I'm going to open this up. So it'll open up just like a normal class, right? We can see at the side we've got a display name, so I'll give it a basic name of print debug string. Can it be interrupted? Sure, it's a string, it's fine. Priority 0, it's not super high priority or anything. Force selection? No, we don't need to force it. Any gameplay tags? No. Base score is 1. Perfect. Over the functions, override, you can see all the functions we've created. So I'm just going to override the execute one. I don't need to do any other one. And inside here, we can now drag off and call print string. And we can promote the string to a variable, and we'll call it inString, that's fine. Make it instance editable, compile and save. To make it look a bit nicer, hit class settings. In the display name, we'll just type print debug string. Hit compile and save. That's essentially your task, really. You make stuff up just like that, however you want to. And you can do all the other logic. You can run a state tree. From the context, if you drag down and click break, you've got all the other stuff. So from the pawn, you can get the AI controller. You can then, you know, run a state tree. You can get the ability system component, and you can say activate ability, you know, and everything else you want to. And if you want to change the score of it, you can come and override the score. You can put your logic in here. Does the farm exist? Return 0. Or you can do that on the can run function. Does the farm exist? False. But by default, it will return true anyway. But that's the basic task here. But you'll notice there's one minor error with it we just need to fix back in the C++, but I wanted to point it out first. So if you right click and do get all actors, you won't be able to do it. If you do get player pawn, you won't be able to do it. And that's because we've used the U object, which is the highest level of Unreal class. It doesn't have access to the actors, it doesn't have access to the world, it barely has access to do anything but very minimal things that's built into the engine. And we don't want to add all that stuff in that it doesn't need, because then this task won't be really lightweight. But giving it access to the world so it can find objects in the world and stuff like that, that's kind of key. So let's go and add that in now. So keeping Unreal open, I'll just jump back to my rider instance here. And what we need to do back on the task definition here is basically say on here, this U object, it's got a function in here called get world there, right? By default, this does nothing, so it won't work, it doesn't do anything. This is the actual Unreal Engine's code. If you go to an actor or something higher level, that get world will be populated and have some logic to run. But we don't want to make ours an actor so we can drag it in the world. That doesn't make sense. So we're going to actually overwrite that and tell Unreal, hey, whenever you call get world, here's what you need to do, and it'll give us access to everything. So let's come and overwrite that function then. Like we can have our functions here that we can overwrite, we're going to overwrite an Unreal one because that's what we can do. So right at the bottom of the public, just under everything, because this one's kind of a throwaway one, I'm going to press enter a couple of times. I'm going to add a comment, allow the object to get a valid U world from its outer classes, and I press enter. So what I'm going to do is type virtual, which means I'm going to override it, and you can see it's pretty much done everything we need. U world, get the world, and then it's going to do const override. So I'm going to click on that and choose generate definition inside here, and it's giving it us right here, and you can see it's returning an empty world. We don't want that. Because again, this task is so high level, it doesn't have access to the world. Now, to write this, there is a chunk of code we need to add in. But again, I'll add this in the description on a link to my website so you can copy and paste. Essentially, what it's going to do is check, is this a special type of class? If it is, just return null pointer. So don't return anything. it's special. That's like if it's a function or something like that. We don't want to deal with that. However, if it's not, then it's going to get the outer, which is essentially get its parent or get the next level up. And then it's going to say, hey, is this outer we've just got, does it have access to the world? If it does, return it. Great, we've now given our class access to the world. But if it doesn't, then get the outer of the outer, so get the parent if you wish, and just basically say get the parent, get the parent, get the parent, get the parent, and keep doing it until it finds the world. And if it gets to the very top and it can't find the world, chances are we're loading this in something weird like a server or something, so it returns nothing. But otherwise it returns the world. That's essentially what it does. So feel free to copy and paste that or type it in. But a while loop basically says while outer is true. So it'll go true, 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 true until this says, hey, I ain't got anything else, no, or nothing. That'll go, oh, okay, let's stop then and come down here. That's essentially it. That's really all you need to do. It's a lot easier to paste it in. But now let's try the hot reload in Unreal. Sometimes it works, sometimes it's really flaky. But I'll come back to Unreal and I'll click this little building blocks button down here that says recompiles and reloads the C++ game for games. We'll tap that. So that should just compile the C++ now without having to restart Unreal. Let's see if it works. It can be a hit and miss. When we get to doing the custom editor utilities, it does work. As you can see here, it was a big miss. It did not like that. So we'll hit close. We'll come back to Rider. I'll cross it off, stop it running just to kill Unreal, and I'll rebuild it. What that error was basically saying is, hey, you're using this NPC task blueprint, but then we've just deleted that because the code's recompiling it. It's like, oh, where's it gone? And then it errored because Unreal really didn't like that. So close Unreal, reload it, and it should load back up nice and prompt. There we go. And when I say it deleted it, I don't mean it's deleted your file you've created. More so, it's deleted the base class so Unreal panics and doesn't know what to do with it. But now if we come back and open up print string, you can see everything will work the same. It saved all the logic and everything great. But now we can right click and choose get all actors of class. Look at that. We've got everything we need. We can get the player pawn, do everything you want. So that's improved it massively. And that is the task system for the NPC setup. Now this video unrecorded is 56 minutes long. It's going to take a while to edit and it's going to take a long time to get through. But what I'm going to do is leave this bit with you. You can go through and create a bunch of tasks now. Set state tree, run behavior tree, play animation, print string, go to location, anything you want, right? And it can run any way you like. I'm going to pause the video here and we'll do the brain component in the next video because the brain component is probably double the size of what we've just done. It is very code heavy, but it's absolutely worth it. So we've done the task today. Next time we'll do the AI brain. Next time after that, we will add in the schedules to it because keep it separate because it's going to be a long video with both of them in. And then we can finally start looking at actually using it in the world, but it's super simple anyway. So thank you for watching, ladies and gentlemen. I hope that was helpful. We have done an absolute boatload of code today, but it is the framework that's going to be absolutely awesome as you saw at the start of the video. And if you want early access to the brain component and all the other videos in this series early, it's available on our Patreon for as little as £1 or $1 something, I don't know the conversions. But then you get access to all our videos early access. We often give free animations out that I really want to get back into doing because it was really cool and it's a great place to be. And all the money goes to supporting us. So thank you for watching, ladies and gentlemen. My name is Decryption and I will see you next time.